this. Okay, so we start with number 12. Find the derivatives of the following functions using the rules for finding derivatives. Okay, so let us start with number 12a. So for number 12a, okay, we are given the function is f of x equals to x to the power 6 plus 1 multiplied by x to the power 4 minus x. X to the power minus. Actually, we can expand this, okay, and then for finding the derivative by the power rule, but no, okay. This time, let us use the product rule for finding the derivative. Okay, so of course, we can write this as u of x equals to x to the power 6 plus 1, and v of x equals to x to the power 4 minus x. And in this case, then by the product rule, we have f prime of x equals to u prime x vx multiply by adding by ux multiplied by v prime of x. Okay, so in this case, u prime of x equals to the derivative of x to the power 6 plus 1 is 6x to the power 5, and vx is still x to the power 4 minus x there. Then ux is 6x to the power 6 plus 1, and then the derivative of vx, v prime of x, x to the power 4 minus x, so it's 4x to the power 3 minus 1. Okay, in the end, we will have, after expanding this, have 6x to the power 9 minus 6x to the power 6 plus, okay, for x to the power 9 there, sorry, for x to the power 9, and minus x to the power 6 plus 4x to the power 3 minus 1. Okay. Okay. Of course, we can simplify this term to obtain f prime of x equals to okay, so the last term is x to the power 9, so I have 10x to the power 9 minus 7 x to the power 6, and then plus 4x to the power 3, x to the power 3 minus 1. Okay, so that's the result. Of course, you can take the product first, so you get actually x to the power 10 minus 7x minus x to the power 7 plus 4 plus x to the power 4 minus x. Then you get also you have the same result for the derivative. Okay. All right. So that's the derivative of the function f. And okay, so let us continue for 12b. So for the 12b, we have the quotient rule, namely the derivatives of the ratio of the function. And in this case, we have f of x equals to x to the power 3 minus 4x plus 1, x to the power 3 minus 4x plus 1, divided by x to the power 4 minus 1, x to the power 4 minus 1. Okay, so in this case, let us write u of x equals to the numerator, namely x to the power 3 minus 4x plus 7 plus 1, sorry, and v of x equals to x to the power 4 minus 1. Okay. Then, if I apply the formula for the quotient rule, I will have this one u prime x multiplied by vx minus ux multiplied by v prime of x divided by vx squared. Okay, so in this case, if I should substitute u prime v, u and v prime, and in the end we have, okay, so let us, in this case we have f prime of x equals to, so u, of course, obviously it's easier to write vx squared, so the denominator should be x to the power 4 minus 1 squared. And then for the numerator, I have u prime of x is, I have u is x to the power 3 minus 4x plus 1. So u prime will be 3x squared minus 4. And then I can multiply it by vx is x to the power 4 minus 1 minus, okay, ux multiplied by v prime of x. Okay, u is x to the power 3 minus 4x plus 1, and then I have v prime of x equals 2. So v is x to the power 4, so v prime is should be 4. Okay, probably I will use the simplify the space, minus x to the power 3 minus 4x plus, plus 1. Oops. Plus 1 multiplied by the derivative of x to the power 4 minus 1 is 4 x to the power 3. Okay, so in the end, just simplify the numerator. Okay, first expand it, 3x to the power 6 minus 3x squared minus 4x to the power 4. So 3x to the power 6 minus 3x squared minus 4x to the power 4 plus 4. Okay, minus, okay, I have 4, okay, 4x to the power 6 minus 4x to the power 4. Okay, 4x, oh sorry, 16 should be 4, because 4x multiplied by 4x to the power minus 16x to the power 4, 4x to the power 3. Okay, and the numerator is x to the power 4 minus 1 squared. Of course, I can simplify this. Okay, so first I have minus x to the power 6 minus 16x to the power 4 plus 16x to the power 4 is 12x to the power 4, and minus 4x cubed minus 3x squared plus 4. All of this divided by x to the power 4 minus 1 squared. All right, so 12c is actually the combination between 12a and 12b. More precisely, we have a product rule and quotient rule as well. Okay, so I will omit it. So let us continue to number 13. So number 13 here is actually the symbolic, or the how to review the rules for finding derivative. Okay, so we are not given the formula of the function, but we are given the value of the function at a certain point, and also the value of the function at the derivative, the value of the derivative of function at a certain point. Okay, so we are given f2 equals to 5, and f prime of 2 equals 3, g of 2 equals to minus 4, and g prime of 2 equals to 6. Okay, so actually in from 13a b, okay, so let us consider 13a, b, c, and d. This is just to recall the rules for finding the derivative. For example, if I consider 13a, the derivative of f plus g at 2 is actually just the sum of the derivative at 2 of f, derivative of g at 2. We just add it. Then we have this one is 3 plus 6, namely we have 9. Similarly, from 13b, the derivative of f minus g is just the derivative of f minus the derivative of g. And in this case, f prime of 2, okay, of course, is 3 minus g prime of 2 is 6. So 3 minus 6 is minus 3. That's the derivative of f minus g. So 13c is just the derivative of the product of f and g. Okay, c, derivative of the product of f and g. F times g prime of 2 is f prime 2 g of 2 plus f2 multiplied by g prime of 2. Of course, we have to insert or substitute the data, but the value of the function and its derivative. So f2 is f, okay, start with f prime of 2. F prime of 2 is 3. Okay, multiplied by g of 2 is minus 4. Okay, plus f2 is 5. Multiplied by g prime of 2 is 6 there. 6. So I have minus 12 plus 30 is 18. Okay, the same applies for the derivative of f over g at 2. Is we just apply the rules for finding the derivative. Prime of 2 g of 2 minus f2 g prime of 2 divided by g of 2 square. Okay, and the same as before, just insert the value of f2, f prime of 2, g2, and g prime of 2. Prime of 2 is 3. G of 2 is minus 4. Minus f2 is 5. Same as before. And g prime of 2 is 6. Okay. Divided by g of 2 is minus 4. So minus 4 squared. Of course, we have 16. And in this case, we have minus 12 minus 30 is minus 42. And if I divide it by, let's say, 2, I have minus 21 over 8 there. Okay, that's the value of f over g. Okay. Number E and F is actually quite similar. Okay? In addition, number H, number F, sorry, we have a new function H defined by the product of gx and x squared plus 1 divided by f. It's basically just the extension of the rules for product rule and quotient rule. All right, so let us move to the number 14. So in the number 14, here, the question is, how do we find the derivative of the trigonometric function? Okay, so we are given a trigonometric function, and then what is its derivative? Of course, we can apply the product rule or the quotient rule or the another rules for finding the derivative, combining with the derivative of the let's say the cosine function, sine function, secant function, tangent function, cosecant, and cotangent as well. Okay, so probably we'll focus on 14a and 14b there. Okay, so let us start with the easiest one, 14a. In 14a, question is to find the derivative of, okay, the given function f of x is 2 cosine x plus 3 sine x. Okay. And this is easy because we just apply the derivative of f, derivative of cosine of x and sine of x, and also the linearity property of the derivative. Okay, so the derivative of sum of the function is just sum of its derivative. And then if the derivative of scalar multiplied by a certain function is just a scalar multiplied by its derivative. So in this case, we have f prime of x equals to 2 multiplied by the derivative of cosine of x, ddx of cosine of x, plus 3 multiplied by the derivative of sine of x. Okay, recall that the derivative of cosine of x is minus sine of x. So I have minus 2 sine of x. And the derivative of sine x is cosine x. So I have 3 multiplied by cosine of x. Okay, do not forget the minus sign in front of sine of x, the derivative of cosine x. Okay, so it's quite straightforward. So let us consider the second question. So the second question, we have the product. Okay, so f of x equals to 3, okay, if I'm correct, multiplied by secant of x, multiplied by tangent of x. Okay, of course, this is slightly more complicated to the first one because it involves the product of the function. And more precisely, we will have f prime of x equals to, okay, so let us use the product rule, okay, and then I can omit 3, just a scalar there. So we use the rule of u, the derivative of u times phi is u prime phi plus u phi prime. So in this case, the derivative of secant x multiplied by tangent of x, okay, that's the first part, and then adding by secant x fixed, and then the derivative of, oops, the derivative of tangent of x. Okay, okay, okay. Of course, we'll have f prime of x equals to 3 multiplied by the derivative of secant of x is secant x multiplied by tangent of x, then multiplied by tangent of x, and then now secant of x fixed. And then I have the derivative of tangent of x is secant x squared. Okay, so in this case, I will have 3 multiplied by secant x tangent square of x plus secant x to the power 3. Okay, so that's the result. Of course, we can simplify it further if we want. For example, if you know the relation between tangent square of x with secant x squared, then of course you can substitute it by secant of x. But of course, up to this point, the answer is correct. Okay, we don't not really need to simplify it furthermore. Okay, so that's derivatives of trigonometric function. And in number 15, okay, I will take a look at one of these. The idea is that, okay, actually can simplify it if we know the chain rule, but at this moment, let us calculate the derivative of the function by using the trigonometric identities. For example, in okay, example in, I will solve 15a here. I have the function f of t equals to cosine evaluated at t plus pi over 4. Okay. 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 So the idea is that we want to use the trigonometric identity to solve this, so to find its derivative. So first, let us apply the trigonometric identity, namely the cosine of the sum of two angle here. Of course, I have cosine t multiplied by cosine pi over 4, and then minus sine t multiplied by sine pi over 4. Okay. Okay, so that's the first step. Of course, we should substitute the value of cosine pi over 4 and sine pi over 4 as well. So I have obviously square root of 2 over 2 cosine t minus square root 2 over 2 sine t. Okay, and then after obtaining this, of course, it's similar to the number 14a. just a linear combination of cosine and sine function. Okay, so in this case, I will have f prime of t equals to, okay, so just square root of 2 multiply the derivative of cosine function minus square root of 2 multiplied by the derivative of sine function. Okay. Recall that the derivative of sine function is cosine function is minus sine. So I have minus square root of 2 over 2 sine of t. Okay. And here I have minus square root 2 over 2. The derivative of sine function is cosine. Okay, so that's it. But actually, you may simplify this. Okay, so actually, you may simplify this term. You may realize this as, okay, if I put minus, okay. But anyway, if you put the minus sign at front, square root of 2 over 2 sine t plus square root of 2 over 2 cosine of t there. Okay, actually can write it as here, let's say cosine pi over 4 or sine pi over 4 as well. And you'll see that this is the formula for the sum, the sine of the sum of two angles. Okay, so precisely if I write it minus cosine pi over 4 sine t plus sine pi over 4 cosine of t, then it's actually equals to minus sine of t plus pi over 4. Okay, but of course later on we'll see that this is this can be simplified by using the chain rule. Okay, just realize that the derivative of cosine function is minus sine, and then multiplied by the derivative of t plus pi over 4, namely 1. So we get the result. All right. So, okay. So that's for the rules for the finding the derivative and the derivatives of trigonometric function. In the next session, we'll continue for the derivative as for finding the equation of the tangent line, and also the meaning of the derivative and second derivative in terms of the moving particle. And then we continue to the second part of the tutorial chapter 2, namely we consider the higher derivatives, the chain rule, and implicit differentiation, related rates, and differential and linear approximation. Okay, so probably I will, at this moment, I will stop here, and then we'll continue for that second part.